Hello, welcome to the presentation. My name is George Carmen, and I teach at Metropolitan State University of Denver, and I teach in the Department of Computer Information Systems and Business Analytics. And I've been at school now for about 34 years, and during that time, I've always taught database management systems. And in particular, I've taught many students how to use the structured query language, which is the language of database. It's fairly rigid structured code that people need to know and understand in order to put data into the database, to retrieve it, to present it, to modify it, so on and so forth. And so you can think of the scenario where there's a manager or someone within an organization that does not know SQL and they want information from the database. And they tell the database professional what they want in clear, concise, grammatically correct English, English being our language, maybe some other language for some other people. But the computer analyst there, the database person, would go and he would formulate or she would formulate the SQL code and answer the manager's question. Well, let's assume for a second that we have a new set of technologies out there, which are these artificial intelligence technologies. And we have in particular natural language technologies that would take the statements from the managers and from other people within the organizations who do not know much about SQL, and it would convert their English language statements into SQL. And we would no longer need that information technology person to intervene. Now, that would be very good. That would be very productive, time saving, and anybody could get at the information. They would not need to rely on other people. They would not need to rely on the IT department and whatever to get a lot of their work done. They would not need to go to a class and sit there and learn things like SQL. All that they would need is to be able to speak in clear, concise, unambiguous English. And that's really what we're going to talk about here in this paper. And so, first of all, I'm going to go through basically what a relational database management system is. I'm going to assume that the viewership out there is not really a technology viewership. And I'll kind of build and get into some of the more interesting AI structures that we have and some of the softwares that are out there and exactly what it can do. So, current relational database management systems. These have been around for a long, long time. And they're transaction processing systems. They're highly volatile. Data goes in, data comes out, data are changed, things are always happening. A great number of transactions here in the data in the database. The problem is that they are not very good at holding historical data. And so if you want to go back a number of years and see exactly what, say, the salaries were 5 years ago, you're not going to be able to do it too well just with the conventional relational database management system. You're going to have to develop something else. And that something else has been around since the 1990s. And it is called a data warehouse. And it takes data from the operational data, which we talked about in previous slides, and it places that data in the warehouse the data, since it's historical there, is non-volatile. It snapshots of what the organization looked like at any particular point in time. So here, whether it's a minute, a week, a year wouldn't really work, but a day, an hour, whatever, we would have an update of the operational database into the data warehouse. It contains data that are internal to the organization. You also can structure the data warehouse so that it holds data from external places, from maybe government accounts, maybe CompuStat files or whatever. It's a decision support system more than a transaction processing system. So we can get into it with a variety of tools, and we can actually do analytical stuff with the data that's in the data warehouse. And we think, we have this decision support system. We have a set of tools here that are called OLAP tools, online analytical processing. Okay? The evolution of data requirements. And initially, everything was in two-dimensional arrays. I think everybody's basically familiar with like a Lotus spreadsheet. You have rows and you have columns, and you have data stuck into the cells there. And a relational database is a set of tables, which are two-dimensional arrays. And we put a number of conditions here on the rows and columns of these tables. You don't need to really get into that now. All the data was structured, meaning that they fit nicely into these two-dimensional arrays. You had rows here of employees, and then in the columns up here, you would have columns that represented their names, their addresses, the department they worked in, so on and so forth. Okay, so it was highly structured. And then along came image files, sound bites, sound files. And there were attempts and good attempts to deal with them. The first attempts were probably not good. They were just large binary files that could be converted to like sound and images and whatever. Then we had something called unstructured data. And data become unstructured when they don't fit into these two-dimensional arrays. And a real quick example here is that, you want to do a rating on a movie, maybe you want to publish it or whatever. So you go see this movie and you could answer a set of questions that are, on a scale 1 to 5, 1 being bad, 5 being good. What did you think of the movie? What did you think of the actors? What did you think of the plot, etc.? And that would be kind of structured data. But then you can write a narrative, and you can say, I generally like this movie, and it had some really good acting, but kind of dull right in the middle of the movie, but the ending was really exciting. But this is a paragraph that you're writing, or maybe multiple paragraphs. But what you're doing here is you are writing a narrative that doesn't fit into some kind of a two-dimensional array. Your data are unstructured, okay? And then after that came big data analytics, where you had data coming in very, very high volume. Let's think Amazon now. People are ordering from everywhere. They might come in a variety of different ways, right? So it's not maybe a single type of data. Maybe a lot of different data are coming in, okay? So you have what are called big data analytics, and we had to handle those much differently. We had to handle those through a system. Well, the initial system was called Hadoop, and retrieval of the data was through something called MapReduce. But this is just a little bit of background as to where we are here. Big data analytics is the big thing out there right now. Structured query language is called a high-level language. It's non-procedural, We don't have to specifically identify each row and column like you would. Some of you might remember BASIC and Fortran and a number of those old languages, or even Python. But it's a non-procedural language. You don't have to write procedural. So they're sort of English-like commands. And SQL is applied to virtually all database management systems, whether they come from Microsoft or Oracle or from wherever. Okay, it is the language database. It was developed long ago by IBM, but IBM no longer owns it. It can be written through commands that roughly resemble English language statements, but they're very, very precise. Okay, we're not talking about just basic inquiries. We're talking about very hardcore, well-established sets of syntax here. Can do, like I think I said before, store, update, retrieve, and process data. And it primarily reads into these two-dimensional arrays, although, you know, there are some advances in SQL. There is a procedural version of SQL, which requires people to open tables and create what are called cursors and whatever, and read data in a specific way and deal with it through a set of procedural statements. And that is going to come up again here in the paper. All right, AI, generative AI. And excuse me, a lot of this is for SQL. And I got a couple of slides in this AI for infused chat boxes. We've all used chat boxes. You know, you are contacting the big box store, and down there in the right-hand corner, you get this little conversational thing. Type in your question. You type it in, and there's not a human being at the other end. There is something called a chat bot at the other end, and that is an AI program. Some are good, some are really bad, as you probably know, but there is an AI program at the other end. Excuse me, it's dry here in Denver today. But what it is this AI program that's going to try to take the stuff you typed in, read the natural English language, figure out what you want, and try to do whatever for you. Okay? And, you know, we talked just a little bit here about what a definition of artificial intelligence is. It can be fairly simple, the capacity of a machine to imitate intelligent human behavior, right? Very, very broad definition. It could be, you know, I'm going to talk about strong and weak here in a minute, but it could be something that's very, very strong, where it can do everything a human being can do. Some of you may remember the old Star Trek where you had Mr. Data, right? Or going way back in time to the what is the Star Wars shows, where they had the two droids that had all these human characteristics. One of my favorites, and I can't remember the name of the character right now, was the computer who turned out to be a negative influence in the initial Alien movie. But we're a long ways from there right now. I don't think that we're going to have Arnold Schwarzenegger, the Terminator, walking around among us for a while. We talk about down here what we call weak AI, and where the human intelligence is only part of a very specific purpose or whatever, to write SQL code or whatever. Take natural language and write the SQL code. Okay? Natural language processing, which I've been talking about is just that. It can take an exact meaning from natural words and phrases, and it can figure out what you said. And if you're really a good speaker, you can say things so concisely that anybody can understand without any ambiguity what you said. And having mentioned that, we're going to talk about some problems in one of the last slides and talk about these ambiguities and some other issues. Okay, natural language technologies allow the user to interact with software. And really what they're going to do is they're going to have a chat box similar to the one that you get when you try to contact the big box store. Okay, and normally going to interact through this chat box, and that's kind of the intermediary between us, people who are speaking clear and concise English, and the program that is writing the SQL code. Okay, and we have to train the artificial intelligence program to know what it's supposed to do. So when it does get some clear and concise language, that it can take it and it can put it into SQL and execute it for us. So this is just a little bit of training we'd have to go through. The AI program, the machine, if you want to just abbreviate it here, must be trained to recognize what the human beings are saying. And then once they recognize what the human beings are saying, they have to be able to identify the code that they must use to answer the questions that are out there. And, there's two ways to do this: supervised, unsupervised. And supervised means that you have an algorithm that has, say, a lot of instances of what you see and what the output would be. And I'll give an example here. It's easier to explain that you're going to teach somebody to recognize what an elephant is. So you have a million pictures, and some of them have pictures of elephants and some of them don't. And so, like flashcards, you're showing the people these pictures: elephant, no elephant. And, the machine answers and it's right or wrong. And eventually, when you get done with a million different photographs, that you've taken photographs from all angles of that elephant, that the system knows what an elephant is, the machine knows what an elephant is, and it knows what an elephant isn't. And that's supervised learning. Unsupervised learning is that you have an algorithm where you give the inputs, but you don't tell the program what the outputs are. And it's a little bit harder for the program to figure it out itself. Okay? But in any event, once the machine is trained, it can continue learning. So, you've trained it as well as you can, but there's still going to be situations where somebody enters, say, a statement, and you have to somehow, you can't get an answer. The system has to somehow figure it out and store the new information in its memory. And this is what I was saying too. We kind of got to hear a little bit from the very first slide. Managers and others can ask a question, maybe to retrieve some data in a very specific format. And you would normally need a programmer to evaluate what the manager or whatever is saying and translate it into a format that is SQL code, and to run it and give the answer back to the manager. And database courses have taught students how to do this. It's a large part of the database course. It always has been. You have to become something of an SQL program. Okay? And software developed through the generative AI techniques take the natural language and convert it to the SQL. Okay? And if you have the program for the AI technique, you do not need to go out and find the SQL programming. And just a very, very simple example here. We usually think of complex situations and complex inquiries into the database when we talk about AI and whatever. But this isn't really that complex, but a non-programmer may say something like, find all the employees by their name who work in management and earn more than $50,000 per year. And the code generating software produces code like I'm showing right here. This is an example of relatively simple SQL code, but I can talk about it briefly because we have what are called tables. So whatever comes up here in the inquiry, it has to lead uh, the program in the direction of figuring out which uh, tables that it's going to have to get to and retrieve the data from. And once it finds the relevant tables, it has to go through the columns and, it has to figure out the names, the employees by name would probably be here in this column, employee name. And you would have to figure out that there are columns called department, and you want that to be only management, and you want salary to be in a range here of greater than 50,000. Okay, so that's basically what the system has to do. Okay, I'm going to go through three of the big programs that are out there, and they're kind of listed here in order from the simplest to one that's kind of in the middle, sort of complex, to this last one, Ask Your Database, which is by far the most complex. And this is a proprietary product we'll look at first. And all of the others do what this first one does. I'll spend a little bit of time with it, okay? And it's called RAG to SQL. And if you have been around for a while and maybe know a little bit of what I'm talking about, and maybe dealt with this a little bit, it had always been called text to SQL. And they changed the name here fairly recently here. Okay, so RAG to SQL is the new name. They've added some features specifically. They've added some features that allow the software to do an execution in the database. Okay, and here's the developer. It was developed some time ago, and it's an open source product. It was developed in a Python framework, which will mean something to some of you. Okay, it's a very, very common programming language out there right now. And it executes natural language inquiries into SQL programming code. And it can go out now and actually execute that code on the database or against the database. Okay, and they found that it performs very well across many disciplines and about all the business disciplines. Marketing, finance, accounting, etc. Right? And this is just kind of an aside here that it's also been established that it can generate formulas for use in Excel spreadsheets. Right. AI to SQL, and I guess this is a proprietary one. And it's a proprietary product. They're going to charge you money to buy this. This is the developer here, Mustafa. And you can go out and buy it. They have different versions. They have a personal version, a pro version, and a business version, and they can all do different things. And you can get online very quickly and just query AI SQL, and you're going to find there's many sites. You're going to get to them very fast, and they'll show you the price. I think the cheapest one is about $10 a month for the personal, and it goes up from there. The business version would allow multiple licenses and uh, unlimited inquiries in whatever database. Okay, so it does basically everything that RegSQL does, and it extends the functionality. It's a plugin, and probably most of you know the super chat box, Chat GPT, and I think there's a plugin too to the Microsoft product Copilot. Okay, and it supports a lot of DBMSs. And these are a few of the DBMSs that it supports. And in addition to writing SQL, it will write functions, procedures, triggers, and whatever in things like Oracle PLSQL. And I found that I can write a lot of things that are fairly good functions just with native Chat GPT. But if, for example, you wanted a function that you would feed it a date and then it would give you an age based upon the date, that would write a function here in Oracle. And some of you, I don't want to get, I am probably gone over my time limit anyhow. I'm up around 27 minutes, but no SQL. So these names may mean something to some of you, but if they don't, that's okay. It's not really that relevant for the paper, but it's a much more powerful product than RAG, the SQL. And Ask Your Database is the most sophisticated, and it was developed by a team of programmers, and they worked for a long time on this. And it's open source, and I think you can actually uh, do an add-on in Chat GPT, or you can just use it directly. And what it does, okay, add-on plugin, and what it does is that queries are written in a natural language and translated into SQL queries. It does a lot of other things, and it does uh, code generation in other languages, and it supports things like this NoSQL and other more modern versions here of structured query language and things outside of structured query language. But it is a far more sophisticated product. Here, I'll dispense with this kind of quickly because you can read it right off of there. What can go wrong? And really a lot of things here. So the author here, these people listed these ambiguities, and you can look through them. People can just type in or misspeak or do whatever. They don't give us a full specification. They don't give us a right syntax, etc. Right? Words can take on many meanings. Artificial intelligence, it's still new, it's still experimental, it has great promise. A lot of people are afraid of it. One of the articles that I read said, when PCs were set in people's desks back in the 1980s, 1990s, that people were freaking out because their jobs were going to be gone. You know that they weren't, right? Probably the same with AI. that AI is going to help us. It still need people. And yeah, it's going to be the cornerstone of business decision making. And while several products are out there, and many of them are very good, one of the things when you go through the literature that you find out is that things are changing very rapidly. And, no grass is growing under anybody's feet. They're out there and they're updating and they're refining and they're doing really good things. And that brings us to the end. Uh, I didn't mean to make a half-hour presentation, but it looks like I did. So if you want to contact me, there I am. So feel free.